Hello, my name is Kevin Kosat, and I'm part of the IcyInverts research team, a collaborative group of scientists from multiple institutions. We're on board the research vessel icebreaker Nathaniel B. Palmer to study marine invertebrates and other organisms that live in the ocean around Antarctica. In this video, we'll learn about a group of understudied deep-sea marine invertebrates, including many of which that don't even have names yet.
One area of study in my lab is the taxonomy and systematics of an unusual group of worm-like mollusks called Aplacopherans. Aplacopherans don't look much like familiar mollusks like snails or clams, but if you look at them under a microscope, you can tell they're related because Aplacopherans have scales or spines made of calcium carbonate, the same material other mollusk shells are composed of. Worldwide, there's only a handful of experts actively working on this group, and pretty much every time I sample where no expert has worked before, I find species that are new to science. What's more, Aplacophora is just one of dozens of groups of marine invertebrates with few or even no living experts studying them. So, who cares? Well, taxonomy and systematics are fundamental disciplines in biology that provide information on the diversity of life on Earth, which is essential to the fields of conservation, ecology, and evolutionary biology, just to name a few. These fields offer the basis for all comparative studies, providing the names by which we call organisms and a framework that explains our evolutionary relationships. Confronted with a vast number of undescribed species and high rates of extinction, marine biologists struggle with the lack of trained personnel and time to discover and characterize biodiversity. This work is especially important in Antarctica, where climate change may lead to the extinction of many species, including some that will be lost forever before they are ever even known to science. I'm working to help bring the study of small marine invertebrates like Aplacopherans into the 21st century, while training students who will hopefully go on to be the next generation of invertebrate biologists. Later in this series, you'll be hearing from some of our student participants who are using a combination of traditional tools, like microscopy, as well as cutting-edge techniques like genomics and microcomputed tomography, shown here, which enables us to study the internal anatomy of precious specimens in a non-destructive manner.
Support for this work was provided by the National Science Foundation and our affiliated universities. Thank you for valuing science and watching this video. For more information, please check our other videos that describe the science, animals, and equipment of our IcyInverts expedition.